problem.
Big F is B minus big F, right? Big F evaluated at B minus big F evaluated.
Look very carefully.
Oh, whoops, F would be minus
So the function that differentiates this is this function. We will evaluate that at G. We will evaluate that at A. We will subtract. So if you want to know the change of a function between B and A, then you should integrate its derivative. If you know its derivative. And very often, if you are in the problem-solving business, whether you're in biology, physics, chemistry, finance, economics, you will often have the derivative of the function. Now, you could also put an x here as a function. Correct, which is a function. You are allowing the upper bound of your integration to change. Like it is allowed to vary. You integrate from A to some number x is allowed to vary. So you are going to pick up a function. Minus, of course, this constant here. What do we call this constant? We call that the constant of integration, which is to say something that tells us something about the initial conditions. So if we know the acceleration, these two things have the same acceleration, they are following the same laws of motion. It doesn't have an initial velocity. So they will have different positions of time. So you will have to account for that. This one has initial velocity. Yeah. So, if somebody asks you to find a function from its derivative, you will say, well, there are many things that will differentiate to the thing that you are asking me to find the antiderivative or the integral. You know that these functions both differentiate to the same velocity function. So if somebody says, find the position function, you can say, I can only do it up to a constant. I can only do it up to a constant. That is to say, I'll have to integrate this thing. Integral of 10 t's. 5t squared and the integral of 3 Let's come through initial conditions. But I don't know who is your calculus 1 professor. I don't solve for constants. I don't use this relationship right here. I will take this constant to the other side if I want to get the function of x. Now, if somebody gives you a derivative and they ask you for the function, you will say, I will have it up to a constant. But then they give you an initial condition, then you are picking up a constant. So, here is the problem. The acceleration of the particle is satisfying some, is given by something like this. E to the negative t. And somebody says, well, give me the velocity function, and give me the position function, and give me the velocity at 10, and give me the position at 10. Of course, you will say, well, I will not be able to do that. Because I will have to integrate the acceleration to get the velocity, but then I will pick up a constant. And then when I integrate the velocity to get the position, I will pick up another constant. So I will not be able to tell you the velocity function and the position function up to an arbitrary constant. But then this person is conducting an experiment and said, oh, by the way, I know where the particle was initially, and I know what the velocity was initially. So it would say something like, the velocity initially was 7. But then that would help you with the velocity. You would pick up the velocity exactly. There would be no constants floating around. And then you'll say, okay, now that you have the velocity function, you would need the position function, so you would integrate the velocity function here. So this would be acceleration being the derivative of velocity. You will pick up the velocity. Velocity being the derivative of position. Integrated, you will get the position. Now you have the velocity function up with no constant because you have the initial velocity. You integrate that, you're going to pick up the initial position up to a constant. Then he said, well, no, actually, I do know the initial position also. Initially, you were at the origin, the point of reference, beginning. Why would you want to begin somewhere else? So, I want here now the velocity function and the position function without constants. That is to say, v of t and s of t. So I'm going to use this. But I'm going to maybe change this to x and this to t's. Because these are what? Just letters. We had calculus too. We're not afraid of letters. Yes, Mr. Tyler? You're afraid of letters? No. So, if I want to solve this problem, I'm going to use this setup here. I'll write it like this. If I'm going to integrate out t, f prime of x dx is what? F of t minus f of a. That is a restatement of the fundamental theorem of calculus. What you come to know in calculus, one, that integration is the opposite of differentiation. Integration undoes differentiation. Integration undoes differentiation. Think about it that way. Now, I want to find the velocity function. I want to find the velocity function. We will integrate the acceleration because we know that the derivative of the velocity is the acceleration, so that if you integrate the acceleration, you integrate the derivative of the velocity, you will pick up the velocity. A to t of the acceleration function will be the velocity function at t minus the velocity function at e. So, if I integrate the acceleration function, I'm going to pick up the velocity function up to a constant. And we are going to need to take this constant to the other side to pick up your velocity function by itself. But that is just algebra. So in this setting here, I'm going to write down what for a. 0 what is A of X? Sorry. Ooh, total trash.
About that.
Oh, really? Oh, you guys are always sleeping 9 o'clock in the morning. I'm allowed to sleep because I was teaching until 10 o'clock last night. And for what year?
5t squared minus.
Sorry?
5x squared minus e to the negative x.
Is equal to what? V of t. What I want. Minus?
E is 0.
I'm almost there. So V of 0.
7.
We'll put it in there. That is to say, V of t is whatever this turns out to be, and I'll give it to my calculus one friend. And that's it. What is this? The antiderivative evaluated at t, the antiderivative evaluated at 0, and subtracted the antiderivative of this being 5x cubed over 3, and the antiderivative of this being plus e to the minus x. Maybe I can just